we are going to go over some of the more interesting and powerful things that we can do with recursion. One of those things is the extremely powerful binary search. And to understand how it works extremely well, we'll have to understand logarithmic runtime, which is a scary word because it includes that scary word logarithm in it. But fear not, I'm here to tell you about the really easy definitions for logarithms. We'll get into that as we explain our problem. So we've briefly mentioned sorting being one of those common problems where basically we take a bunch of data and we sort it, and ta-da, we end up with all the items from the smallest order to the largest order. Searching is a very common problem as well. It says, given this stack of data, I want to find something in it if it exists. Maybe I want to find it if it exists, tell me whether it exists or not, or maybe give me its position if it does exist. The biggest factor in searching is whether or not the data that we're searching over is sorted or unsorted. If it's unsorted, then the best we can do is just take a look at all n items and see, hey, is any of those n items the item we're looking for? And if it is, return it. That's going to take O of n time, and there's no real good way around it. On the other hand, if it's sorted, we'll see that there's a trick we can use that allows us to do binary search. So, but let's go ahead and write an O of n recursive search algorithm. Right? Well, let's do non-recursive first, then we'll do recursive. So public static int linear search. Right? Let's do it non-recursive first, which is that. And we're going to use an array instead of a list here because that's just easier. So int array. And we'll just simply do for I is equal to 0, r dot length I++, return, so int loc for location, and we're going to set that equal to -1 because we're going to use that as the default, saying that if we can't find it, then I'm going to return the index -1. Otherwise, I'm going to return a valid index. For int I is equal to 0, I is less than array.length. What do? I should do, if, right? And now the other thing I need is, let's turn this in, yep. Let's keep it integers to keep it simple. Int target. If if the ith thing in the array is equal to target, return I, because that's the index we found it at. Great. So that's our linear search function. However, if we want to change this to be a recursive function, let's go ahead and see what that would look like. Let's see. So let's go ahead. So we're going to need a bit more data than that. We will need so let's make a private function to keep this separate. Private static int linear search, and so it needs the array that we're going over, int array, int target, int index to represent the index that we're currently at. So first thing we'll do is that if we need a base case, a way to know when to stop. If array.length, so if index is greater than or equal to array.length, so if we're looking at an index that is out of bounds, we'll just return -1. Otherwise, what I'll do is I'll say if array index equals target, and again, what I'm doing here is I'm making everything a local decision. That's what basically, so I'm only ever going to look at one index essentially. Return index, and if it's not equal to that, I'm going to go ahead and return array or linear search array for the target, and I'm going to look at index +1. Right, I'm going to look at the next index. And so now what I'll do is that I am going to... So generally, though, when we write these kind of functions, we like to keep things so that... we like to keep it so that the user doesn't really have to worry about this factor that changes. They don't have to worry about starting at 0, right? We don't want them also to accidentally start at maybe index 5 instead. So what we end up doing is we will just create basically this as a private recursive function and a public function that calls it. So a lot of times you'll see me do this. This linear search or return linear search array target and then starting at index 0. Right? So this is what the user will use, and this is how it actually works. Right? So this will ensure that we always start at the correct location. Let's go ahead and test it. So let's make an array. Int r is equal to six, 7. So let's go ahead and look at linear search R for 7. And that should give me index 5. If I say I want to look for 20, it should give me index 7. And if I look for the number 100, it should give me -1 to represent that it is not there. So it works just fine. All right. So we are going to go ahead and now, what we're going to do is that we are going to go ahead and look at how binary search works by playing a very simple game.